Today, my dear YouTubers, or followers, or whatever. Wait a second. Might be good. Today, we talk about Ignitech and setting up aftermarket programmable ignition for either 4-strokes, but in this case 2-strokes, and how to easily get rid of all confusion that the manual is allowing you to make. The base advance is setting that leaves many in what do you call it? Confusion. And it is easier actually than you might think. The base advance, in short, is for compensating for the lobe on the flywheel or whatever isn't long enough to give you the advance you are aiming for. So let's say, now we're getting deep directly. So let's say you want 35 degrees of advance and the lobe is just 25 degrees long. Then you compensate with that to get the trigger 10 degree moved, and you're saying to the computer and program it later that you have 10 degrees of base advance. Doing it like I'm doing it, you're always having the base advance set to 0. And how am I possible to do that then? Yes, it's very easy. If wanting those 35 degrees of advance, the lobe on the flywheel or trigger wheel or whatever should never be less than 35 degrees. You can have it more, but not too much, because having it too much, you decrease the coil's charge time, so to speak. And you need to have that also. So let's say you want 35 degrees in total. Let's make a lobe that's 40 degrees. Then you have some extra to go by. And I'll show you on my overkill engine how I've been setting it up, but it's quite hard to show you as the trigger is behind the wheel that drives the inlet disc. So I'll try to show you right here first, and then we'll go back to the computer as I made a sketch, and I can show you a little bit more in detail, but I'll show you first right here. So I'll turn the camera around and we'll go from there. Cut and make something cool of this. Well, here it is. Here it is. Let's first set the engine in top dead center. First we need to set the top dead center. It's the main thing to do. I'm about to make a pointer that's showing me a mark that I will set on this one. This is the pulley for turning the disc. I will slightly just like that, so I can turn it and make this pointing device. Just a welding rod and some, I can put it, so I put it over here. Should be rigid and stable, but it's good enough if you know what you're doing, so you ain't what do you say, touching it and bending it So what I'm about to do is to make this pointer, and then later, after this is done, I'll just go ahead and find the middle spot between 2 points. I'll show you what the effing F, like that, and I'll make it like that, and then take it off there, make a that's good enough. Now it will be some parallax error for you guys, but I made a mark, yeah, whatever, I can polish that. So I made this contraption, an old spark plug and a 1mm6 nut welded onto it. That has 1mm thread pitch, so it's good in more using areas. But at this point I will only use it as a piston stop. I'll screw it in on top right here, and let's pull it downwards some. Let's see. There we got a hard stop. I don't know how high this one is, but you catch my thing now. You got a hard stop now, and I've got it way too far. No, maybe not. So I'll mark this out. There will be some parallax error for you guys, as I said, but I'll mark this right here. Then turn the engine. And there we got a hard stop again. And exactly in the middle of these two is the top dead center. But this is a little bit spread apart, so I will take this 2 turns up and do it over again. It's too little. Take a lot of turns. About there. Ignore these ones then. There we got a new stop. Then I'll turn it. I actually found TDC right there. 1 turn down. So I'll take away that pointer. There we got it. Hard stop. All around. Backwards again. Some compression though. And we got it right there. It's a hard stop. Now in the middle of these two we got TDC, and I need to measure. Right here we got about 15.8 divided by 2 is 7.9. Yes, 7.9. Oops, a little bit too much. Right there. 7. Now I'll make a little bit of a mark. Oh, that was odd. I must have calculated wrong. Do it again. That's 14.3. That's 7.3. 7.3. Right there. Now we got, I'll mark up with my pen. 7.3 right there, and check it from the other direction also. Yes. So this is the TDC. Now I have to take that one, the spark plug stop out. It will be easy to turn the engine now, has no compression. And I always turn it clockwise, but it shouldn't matter. But right there is TDC. So here's our starting point. Everything should start from here, and now let's move on over to put on this one. So to be able to mount this one, I of course need to take this one off, but the engine is in TDC now. I haven't put any locking devices on it because this is just a guide, and in the end I have made it so I can adjust a little bit when I'm checking zero with the timing light. But there it is. Now this one can turn, of course, if you thought I made a mistake. Oops. I do not need the TDC at this point. I need to take this one away. It became a little bit long, so I'll just pull it away like that. Take that one off. And now this one, as I have a homemade balance shaft contraption right here, this is homemade also. I needed to make a cut to get that possible to be adjusted. Where is it? And then you put it about in the center of the adjustment slots. And when I made this, I thought it was 60 degrees between, let's say, 0, 120 and 240, but it wasn't. So I needed to file this one up a little bit to get some adjustment. But it's working, no biggie. And like that. Let's see, where should we put it? In the middle of that one? No, in the middle of this one. And I got adjustment like 5 millimeters to one direction, a little bit more to the other. It should be good enough. Right there. Do not need to tighten those. And now the important part. If you're reading the manual of Ignitech, you need to point the falling edge of the, this is the, I can talk a little bit about that. This is a lobe that's rotating with the crankshaft. Yes, it creates a little bit imbalance, but it is so very little. That's why I kept it so to the center. If it's been further out, and I have the sensor right out here, which would be easier by having the sensor there, but this would create more imbalance, so I would have been needed to compensate for that. But in this, it's so very little when it's so close to center. This one is about 60 degrees long. A little bit long, yes, but it will work. 59.8 I think I measured it too. It's not dead on accurate, but you need to set the falling edge of the signal. This is this one is rotating anti-clockwise. Let's mark this up a little bit first. Let's put it straight right there, and then we are about there, and we are there somewhere. The falling edge is when the lobe very much when it's leaving the center of the it's a little bit like 5mm steel sensor tip that's sticking out from the sensor. The falling edge should be located at the center of this one. You follow me? The falling edge, which will be that one now turning it like this. The falling edge should point to the center of the sensor steel tip. So I'll put it right there right now. It isn't super important right now because I got adjustability. I can move the sensor later on, but you want to be in the ballpark. So I'll just do that. I got the mark right here in the middle of the sensor. And it is about there. Then I need to go get my plastic mallet and tap it a little bit. I'll just tap it so it's getting a little bit stuck in the cone, tapered part, like that. So now I can tighten this one. Hope it doesn't move. Yeah, felt good. So now I can redo that finding TDC spot again. I'm taking this apart and I will need to be certain where it is. I'll do this again. So now we established that. I put the sensor. Now I need to verify. So did it correct? You can see this, but I will post a picture up in the corner so you can, or I'll, yeah, whatever, put it in here so you can see. And it is correct, as I can see. Yes. I'll pause for a little bit, come back to you. I started hooking up things. As you can understand, this is only temporary. Coil, orange wire to orange. No. Wait a second. Ground. Orange wire onto red. How is this hooked up? It isn't me that has taken this off a bike earlier. What does it say? Battery and switch. Well, I think I'll just the red one's coming out of this one. I need my glasses. The coil, I know, is driven by the positive is output from this one. This is wrong. This is somebody has made some big mistake. There could have been some shortage. So what is this one then? This should be like that, and the coil is driven by Ignitech directly and then grounded. But this coil is grounded in the body, I'm guessing. Coil, orange to orange, with just a yellow cable in between now. Like that, and I'm guessing as there aren't any more connections on this one, this one's bad, there aren't any more connections on the coil. There actually is grounded inside the body, as I said. That was really bad. I should change that one, but not for today. Not for today. No, the spade connector is good. So I need to ground this and grind. I need to ground this. I got minus, negative and positive. That's actually the only one I need. And I put the ground onto the engine and onto the battery. Battery. I have some on. This one's a huge I can then take whatever point I want to. This one I'll need to, I'll take that one. I'll take that one. Ground it off right here. Okay. Well, it's making good ground then. They have made a self-made copper ground spade connector. Now we got that, and I can put power minus right there. And a positive power. Very strange markings. That didn't work. That did work. And big red. big red. This will be the power. This will be the power, yes. Onto the battery later. Oops. Onto the battery later. Onto the battery. I'll go get my battery. I got a big one. I got a big one, as I said. And now I can put this one down here. And I need a screw. Wait a second, I'll pause. Putting connections in. No, we just cut that one. I need to redo this one then. Oops. Oops. What the? What the heck? What's that then? Like that. And then negative. I can just put a new cable from anywhere as I grounded this. I put a new cable onto the engine to the ground right here. And I need a longer, I don't need black, but it's more easy to keep things apart. This is the correct tool for crimping spade connectors, nothing else. Remember that, guys, nothing else. This is the correct tool. You see? Perfect. And I can take this one and put it right there. And then we use this one. That one into there. So now we got a closed loop soon. Let's recheck. Positive on positive. Negative onto ground. Coil is grounded. From ground to negative. It doesn't burn. That's good. So, do we actually have any spark? Do we actually have any spark? This one's correct there. And that one I need a battery. Battery. Now we should have spark right there. It's working. So Now we established spark, and I need to now I need to connect the timing light and connect the laptop onto this one somehow and reprogram it. So I'm setting the all ignition values to 0, as I want it to be 0 right here. So I'll start the computer and hook that up and get back. So here I am. I have connected everything. I have had some small issues. I had the new software and I tried to update the old Sparker box, but it wouldn't take it, so I needed to find an older software, and now it's working. No big issue. It's just, yeah, things that happen. So now I've connected the timing light to the spark plug, of course, over here to the ignition wire. And I got spark. You can watch. Don't know if it appears as it should. And I haven't got this connected, so the engine sounds strange. So now it turns, and I got TDC marked right here. And in adjusting software, come with me, I have put the base advance right down here, if you can see, 0 degrees. This is important, doing it my way, and it also makes no confusions about how to put it, because 0 is 0, and I like 0. So keep on with it at the engine, and oops. And now, when turning it, I can't have 3 hands. I should have 3 hands. Let's see if we can a little bit more. See if you can see. Yes, you should be able to see. When the timing light is flashing, that mark and the pointer should be equal to each other. And I don't know if you can see it, so we'll just go ahead and try. It's dead on. It's dead on. So in this case, 0 is 0. And it's done. Then you just build your own timing curve. Then you build your own timing curve. This is not the curve I will use, but it's a curve in a way. It's for a high revving engine. I do not rev this one about 10 grand, I think. This have been on the engine that revs all the way up to 15,000 RPM. So I need to shorten up the curve and make some changes. But this is not the final curve, as I said. So I checked. 0 is 0. Let's check another thing. I measured the lobe right behind right here to about 59.8 degrees, 59 to 60 degrees. So let's see what it says the lobe is. It should say it down here somewhere. Not there. I don't know where. Maybe it isn't possible in this old software to see that. Maybe it is possible. Huh. Let's see, I got voltage right here. And let's see if I get any values showing up. Well, it actually says right here, it comes a value. I measured it to about 60 degrees, but it says 69 degrees. I don't know why, but that's the most advanced available. So that's the physical setup of zeroing out the TDC and zeroing out the timing, not the timing, the base advance. You should have set that to 0. And the important, oops, where are we? The important part is the lobe on the crank. Listen carefully now. The lobe on the crank should be as long as the most advance you're aiming for, at least. So let's say you're aiming for, let's take a round easy number. Let's say you're aiming for 40 degrees of advance. And the lobe should be at least 40 degrees long. In this case it's 60 degrees long, but software says 69. I think it is due to some latency in the racing and trailing edge. However, as long as that is solid and doesn't change, it's nothing to worry about. Having a shorter lobe, you can compensate for that. Let's say you want those 40 degrees of advance, but your lobe is only 10 degrees, or it's Swedish. The lobe is 30 degrees long. Then you need to compensate by moving the lobe 10 degrees further back, and then set in the software base advance 10 degrees. Then you are compensating for not having enough lobe. Am I explaining it good to you? I'll do it once more at the computer. And let's set early in the RPMs. Well, you can see it actually. Let's say I'm setting a quite high value early. I'm setting, I'm setting 30 degrees early program. At 1000 RPM, when turning it with this and showing with this one should suddenly, the markings should suddenly be at 30 degrees before. So let's see if that happens. At 1000 RPM, so this one revs about 2500, so I should be able to do it. So first, there, and let's just hit it. You saw it first it was right there, and then when I hit above 1000 RPM it became about there, about 30 degrees. And in this case I'm able to have ignition all the way about there if needed to, but I won't ever need that. If running running pure nitro, maybe. Pure nitro methane will take a lot of timing. So that's that, and let's set up the belt for this one, but I will not time it in very carefully. I'll just set it up right now so it will be able to start. But I won't start it today. I haven't got any exhaust and all that. So this is bottom dead center, and then just take about, let's see, right there, about there. Piston has started to move upwards. Piston has started to build some low pressure zone in the crankcase, and then at that point I want to start opening the disc, and we got that right there about. So this isn't actually perfect. I'll hope you understand me. I built this so I got adjustability. I can turn this loose and move the disc a little bit without moving the crank. And these slots are longer than one cog on the pulley, so I should be able to fine adjust as much as I want. So let's see. It just should start opening right there. And let's put on the pulley. Not put on the pulley, put on the belt. Right there. It's good enough. So now the engine should start pumping. And you should hear boom, 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 boom. Yeah, that's it. Let's go to the computer and talk a little bit about this base advance and having it set to 0, and the importance of following my tech tip of having long enough lobe. So we'll go over there and I'll shut this one off for right now. So let's try to explain something. I need a pointing device. I haven't got any, so this old file will do. Yeah, so here we go again. This is my setup and this is my way to do it, but I recommend doing it like this when you're having possibilities to do it, and not having the possibilities. Let's say on that Yamaha I took as an example, just make the lobe longer somehow in welding or whatever way you choose to do it, because everything becomes so much easier. And in my case, this is the trigger, this is the sensor, this is the trigger wheel, and this is the lobe on the trigger wheel, and I got anti-clockwise movement. And the sensor's middle point should be at the falling edge of the lobe. This is the rising edge, this is the falling edge as it moves this way. And in my case it became 69 degrees long, a little bit much, but it's working. And so never mind that, it's working. But as you can read right here, length of the lobe, the length, minimal as long as the most advanced you want. Let's say you want 40 degrees, then the lobe should be at least 40 degrees. And then setting piston at TDC, top dead center. Trigger disk location at sensor. Trigger this location at sensor when piston is at top dead center. The piston somewhere over here. So let's say piston is at top dead center, and you put the sensor at the trailing, the falling edge of the sensor. Having clockwise rotation, the sensor should be mounted over here because it's going the other way, of course. And making it like this, if you're following this strictly, the numbers aren't, as long as you're higher numbers than the most advanced you are aiming for, it's all good. And doing it this way, my way, you don't need to set any base advance that confuses you. You can set it at 0 and timing the ignition as I showed you earlier in the video with the timing light. So 0 is 0. That makes it very easy to later on fiddle around with this and always getting it at point every time. So with this, I'll turn the camera around now and we make a little outro. I'm not good at outros, but this was a guide. I tried to make a guide so you can easily understand how to set up that Ignitech ignition and make no mistakes and having it to work immediately. So with that, I'll sign off and wish you all good luck and take care out there. Bye. This is a view of the DC Dip 92. That's not the latest software. I wasn't able to get it into the. I wasn't able to flash the ECU. But however, I have set up an ignition curve. As this is a 250cc engine, I won't rev it above 10k probably. I've set the RPM limit at 10.5 as yeah, well, you should have some space to make mistakes when you're shifting gears. I will probably shift gear at 9,500 or something like that. And this is just me putting in something. I will run it on methanol so it can take quite high ignition values if not having high compression. And this engine right over here, it is quite high compression, so I can't have these super high values. I would actually use normal values. This is let's see, 12 or 13 degrees. And a little bit of a explanation why the curve is looking like this. It is when the engine comes into the pipe, it's actually getting, compared to a four-stroke engine, it's getting supercharged or over boosted, so to speak. And by that, having higher volumetric efficiency or more stuffed into the combustion chamber, you need to lower the timing, because when having a higher more compact mixture, the particles, fuel particles, are closer to each other but still surrounded by air, and it's very compressed and it's very tight, and when firing that, it will burn really quick. So when the engine is heading into the pipe, it becomes supercharged, and you need to lower the timing. An engine without a pipe, let's say an old vintage bike, it doesn't need as much timing retard. It might, let's say you got in this engine 33 degrees, and you might have 20 degrees, 25 degrees at top, because the passive exhaust, as I call them, they have some sort of little bit of a supercharging function, but not as good as a real tuned pipe. So that's why you're doing it like this. And I hope that clears up things. Also, a thing to think about when designing ignition curve for a two-stroke is that, let's say, the timing point you have at, say, 8,000 RPM at this point. It's a product of no. Let's say the engine's function at 8,000 RPM. On a two-stroke. That's a product of earlier RPMs. So, if wanting to have this amount of exhaust temperature, let's say 600 degrees at 8,000 to 10K, you might need to start lowering the timing early to build some exhaust temperature. If having, let's say, 550 degrees at 9,000 RPM and wanting to have 600 degrees somewhere in the region afterwards, you need to lower the timing earlier. But not too much, because you can lose some torque engine is making. So it's a balance where to do this and that, what you want to sacrifice for gaining over rev, or do you want that torque build up and don't give a damn about the over rev. It's a little bit give and take everywhere in the RPM band in the two-stroke, especially if they are like drag racing bikes. They're just throwing through the gears, bop, 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 very fast, and then it's over. On building on a timing curve for let's say a engine that's more static on an RPM, let's say a scooter or something, it's easier because you can use that torque to get the variator to give maximum acceleration. But later out on the track you might need some RPMs to get top speed, but you do not need to take away as much timing, because the heat is climbing anyway, because it just sits there at let's say, in this case, if this was a CVT engine, it might sit on 7,000, 7,500 RPM for, let's say, if it's running on the quarter mile, it's running a 10-second pass. It might sitting there third of a pass, and that's 7.5 seconds. It might sit on this high region and just building heat, and when the CVTS is fully done its job, it's up to the engine to over rev a little bit to gain some top speed, and you built that heat in the exhaust too, so the pipe tune will move upwards, so to speak. And it's easier with CVT engines and harder with geared engines. So you need to find that balance.